In a fire station in Livermore, California, there is a light bulb. It hangs from the ceiling, dangling from a simple cord. It isn't an LED. It isn't smart. It doesn't connect to Wi-Fi. It is a hand-blown glass sphere with a thick carbon filament inside, and it is glowing. Right now, as I speak, it is glowing. That wouldn't be remarkable, except for one detail. That light bulb was turned on in 1901. It was turned on before the Wright brothers took their first flight. It was turned on before the Titanic sank. It was shining while 2 world wars changed the map of Europe. It was shining when we landed on the moon. And it is still shining today, while most of us hold smartphones that will likely need replacing in 2 years. For over 120 years, that bulb has refused to burn out. It is called the Centennial Light. People travel from all over the world just to look at it. They stare at it with a mix of wonder and confusion, because it defies everything we have come to expect from the modern world. We have been trained to expect that things break. We expect batteries to die. We expect screens to crack. We expect washing machines to have a 5-year cycle. We accept this as the law of physics. We think it is the natural order of things. Entropy, decay, the end. But that little light bulb in California is a silent witness to a different reality. It suggests that we can build things that last. We had the technology in 1901. We had the chemistry. We had the engineering. So why don't we have it now? Why does the technology in our pockets, which is 1,000,000 times more advanced than that bulb, feel so much more fragile? The answer isn't bad luck. The answer isn't just cheap manufacturing. The answer is a decision. A specific decision made by a specific group of men in a specific room almost 100 years ago. They didn't decide to make technology better. They decided to manage how long it should last. At the time, this was not framed as deception. It was framed as efficiency. This is the story of the Phoebus Cartel, and it quietly reshaped how value is created and lost in the modern world. To understand the shift, we first have to visit the world before the change happened. Let's go back to the dawn of the 20th century. This was the golden age of engineering. The mindset of this era was heavy. It was solid. It was built on iron and brass. When an engineer in the 1920s sat down to design a product, he had one primary obsession: quality. In the minds of men like Thomas Edison or Joseph Swan, electricity was a miracle. It was the force that would banish darkness. And the vessel for that miracle, the light bulb, was treated with reverence. Factories across America and Europe were competing on one metric: longevity. They advertised it in the newspapers. Our bulbs last 2,000 hours. Ours last 2,500 hours. Ours will outlive your house. It was a race to the top. The filaments were thick. The glass was robust. The vacuum seals were perfect. By 1924, the average lifespan of a standard light bulb was 2,500 hours. Some companies were testing prototypes that could last 5,000 hours or more. Imagine buying a light bulb when your child is born, and that same bulb is still working when they graduate from high school. That was the trajectory engineering was on. Science was doing exactly what it was supposed to do: solving problems. Engineers were heroes. Their job was to defeat decay. If a customer bought a product and it broke a year later, the company felt a sense of failure. It was a stain on their reputation. We were moving toward a world where durability was expected, not celebrated. At the time, no one thought this was strange. This was simply what progress looked like. But there was a flaw in this dream. A flaw that the engineers didn't see because they were looking at the schematics, not the balance sheets. The flaw was simple. If you sell a man a light bulb that never burns out, you never sell him a light bulb ever again. The crisis didn't start with a bang. It started with a sales chart. By the mid-1920s, the biggest electrical companies in the world, Osram, Philips, General Electric, started to notice a pattern. Sales were flattening. The market was becoming saturated. Almost everyone who could afford electric lights already had them. And because the bulbs were so reliable, they weren't coming back. Imagine being a CEO in 1924. You have factories. You have thousands of workers. You have supply chains. This machine needs to be fed. It needs cash flow. But your product is too perfect. It is sitting in people's living rooms, shining brightly, refusing to create a repeat customer. From a purely financial perspective, every additional hour of lifespan reduced future sales. Every quality improvement by an engineer was actually a problem for the shareholder. The logic of the market began to change. Executives looked at the Centennial Light in California not with wonder, but with concern. To them, that undying bulb wasn't a miracle. It was a financial liability. They realized a difficult truth about their business model. A product that lasts forever is a commercial disaster. In that system, efficiency stopped being rewarded. Durability became inconvenient. They had built a trap for themselves. If they continued to compete on quality, they would eventually sell the last light bulb on Earth, and then the business would stall. So they had a choice. Option A, accept that the market is finite. Option B, find a way to encourage repeat purchases. They didn't choose option A instead. They decided to rethink the rules of commerce. For thousands of years, the goal was, make the best product possible. These men decided to rewrite the goal. They decided that the new objective of engineering was not to create immortality. It was to engineer cycles. But no single company could do this alone. If Philips made a shorter light bulb, everyone would just buy General Electric. If they wanted to change the market, they had to do it together. They needed a truce, and so letters were sent. Meetings were arranged. The heads of the world's largest corporations packed their bags. They weren't going to an engineering conference. They were going to a meeting to decide the future of the light bulb. The destination was Geneva, Switzerland. The year was 1924. It was Christmas, 1924. While the rest of the world was celebrating, a group of very serious men gathered in the cold of Geneva. They arrived in black cars. They wore heavy wool coats. They represented the titans of the electrical world: Osram, Philips, Compagnie des Lamps, General Electric. They didn't meet to discuss how to bring better light to the world. They met to discuss a problem: competition. Competition was driving prices down. Competition was driving quality up. Competition was good for the consumer, but it was difficult for them. So, under the gray Swiss sky, they signed a document that would shift the history of manufacturing. They formed a cartel. They gave it a name: Phoebus. Phoebus is another name for Apollo, the god of light. The Phoebus Cartel was the first global organization dedicated to a single purpose: to standardize the lifespan of a product, to stabilize the market. They didn't just shake hands and agree to be less good. These were Germans, Americans, Dutchmen. They loved bureaucracy. They loved science. They turned lifespan reduction into a rigid science. The goal was specific. At the time, the standard light bulb lasted 2,500 hours. The cartel decided that the new global standard would be 1,000 hours. Not 900, not 1,100. Exactly 1,000. They calculated that this was the sweet spot. Short enough to require regular replacement, but long enough that customers wouldn't revolt. But how do you enforce an agreement like this? How do you stop a rogue engineer from accidentally making a good light bulb? You punish them. The cartel set up a central laboratory in Switzerland. It was a compliance center. Factories were required to send samples of their bulbs to Geneva. The bulbs were screwed into testing racks and left to burn until they died. If a factory sent a bulb that burned out at 800 hours, they were fined for making a poor product. But if a factory sent a bulb that lasted 1,500 hours, they were fined even more. Imagine that dynamic. A factory manager getting a fine because his product was too good. Imagine the engineers, men who had spent their lives trying to extend the life of the filament, now being ordered to reverse their progress. They had to experiment with inferior materials. They had to thin the glass. They had to apply all their brilliance to meet the new lower standard. In 1924, the definition of engineering changed. The best engineer was no longer the one who made the best product. The best engineer was the one who knew exactly when it should fail. No laws were broken that day. At least, not by the standards of the time. Something older was. By 1925, the plan was working. The lifespan of light bulbs across the world dropped. 2,500 hours became 1,500, then 1,200, and finally the target, 1,000 hours. Sales recovered. Profit stabilized. The Centennial Light in California kept burning, a relic of a different time. But the world had accepted the new normal. Now, you might be thinking, that was 1924. That's ancient history. And you are right. World War II eventually broke the Phoebus Cartel. The lawsuits in the 1940s officially dissolved it. But the idea survived. The concept that a product should have a predetermined lifespan became a standard part of industrial design. Look around your office. Do you have an inkjet printer? Inside many printers, there is a microchip that counts the number of pages printed. When the counter hits a specific number, the chip sends a signal. The printer stops. It flashes an error message. Service required. Is the printer physically broken? Often no. The motor is fine. The heads are fine. But the software has decided that the cycle is finished. There are tools online to reset these counters. When you reset the number to 0, the broken printer often works perfectly again. Functionally, it works the same way as the fines in Geneva, or consider your smartphone. A few years ago, it was revealed that software updates were slowing down older models. The stated reason was to protect the battery, but the effect wasn't just technical, it was psychological. Your phone felt sluggish, apps opened slowly. And what was the natural reaction? Most people didn't replace the battery. They felt frustrated. They felt left behind. And they went out and bought the new model. This is the legacy of Phoebus. They don't need secret meetings in Switzerland anymore. They don't need fines. The failure is often integrated into the design itself. Over time, technology became normalized as disposable. It is often assumed that because technology advances so fast, older devices must be obsolete. But often, that is a choice, not a necessity. Cars in the 1950s were simple enough to be fixed with a wrench. Now, the hood is often sealed with proprietary screws that only the dealer can open. We shifted from being owners to being users. We occupy the device for the specific amount of time that the manufacturer intended. And when that time is up, the screen goes black. So, what is the cost of this model? It isn't just the money spent on a new phone. The real cost is physical. Because things don't just disappear when we throw them away. There is no away. Imagine a landscape in Ghana, or India, or China. Mountains of plastic and circuit boards. This is where the logic of 1924 ends up. Old monitors, dead washing machines, millions of light bulbs. They pile up. This is the graveyard of intentions. Every single item in that pile was designed by an engineer. Every item was manufactured in a factory. Every item was bought by someone who worked for their money. And every item ended up here, often prematurely, because the business model required a replacement. We didn't lose durability because we lacked the technology. We lost it because it was too expensive for the system to let things last. It is a global cycle. We dig minerals out of the ground. We ship them to be assembled. We sell them. We use them. We bury them. We are converting resources into trash at record speed. Innovation accelerated. Permanence did not. In the 1920s, the cartel argued that this was necessary for the economy. They said if products lasted forever, factories would close. They sold an idea that went unchallenged for decades. Consumption is prosperity. But looking at the scale of waste today, we have to wonder if that calculation was correct. Let's go back to Livermore, California. Back to the fire station. Back to the Centennial Light. It is still there, hanging from the ceiling, glowing with that soft, warm orange light. It has outlived the men who built it. It has outlived the Phoebus Cartel. It has outlived the engineers who tried to shorten its life. It hangs there as a silent reminder. It whispers a truth to anyone who looks at it. I am not a miracle. I am what normal used to be. The Phoebus Cartel is officially dead. But the philosophy of Phoebus is all around us. Over time, ownership became temporary. We have accepted that we are renting our experience, one upgrade at a time. But maybe, just maybe, next time we are in a store, next time we hold a sleek, shiny new box, we might remember the men in the heavy coats in Switzerland. We might remember the date of death coded into the silicon. And next time something fails in our home, next time the screen goes black or the motor stops spinning, we shouldn't just get angry. We should get curious. Ask the question that rarely gets asked. Did this die by accident? Or was it a decision?